All right, what up, guys? We have our quiz 5 review here. Let's hop right into it. So, for each function, determine the real zeros and state the multiplicity, describe the end behavior, and sketch the graph. Here we hop into it. So, first of all, the real zeros. Reminder, this is when you plug in for x, the result is 0. Basically, what's going to be happening is on all of these questions, you have to plug in a value, and that value must result in the problem being 0 entirely. So for each one of these x's, there's going to be a 0 here, a 0 here, and a 0 here. So each one of those zeros, the very first one is a quote unquote obvious one because it's just going to be saying 2x squared equals 0 because you're effectively solving three equations. 2x squared equals 0, that you can't even see what I wrote. 2x squared equals 0, and then you're doing x minus 5 equals 0, and then you're doing x plus 2 equals 0. All three of these are quote unquote simple equations. You solve them up really nice and neat. You got x equals 0, we have x equal 5, and we have x equal -2, and you solve all of them. So every single one of these also has a multiplicity. The word multiplicity, where that word is coming from in the event that you might have forgotten or didn't quite hear it, it's how many times the answer is multiplied. So for instance, this x minus 5 has a cube on it, so it really means x minus 5 times x minus 5 times x minus 5. So that 0 of x equals 5 has a multiplicity equal to 3 because it shows up 1, 2, 3 times. It's effectively just the exponent. So in this case, x equals 0 has a multiplicity of 2, and the x equals -2 has a multiplicity of just 1. Oh, I was about to write -1. Then after this, we do need to state the end behavior. In order to do the end behavior, what you need to do is you need to multiply all the stuff that has x's together, not forgetting their power. So I'm going to do that in pink here. So we're multiplying 2x squared times the x. Don't forget it's to this power, multiplied by this x to just a 1. So if we're writing down our leading term here, our leading term is going to be 2x squared multiplied by x to the third power. So you have 2x squared, then x to the third power times x to the 1 power. Overall, that is 2x to the power of 6. There are 1, 2, 3, 4, 5, 6 x's total. 2 plus 3 plus 1 to get to that power of 6. You are adding, by the way, not multiplying. 2 plus 3 plus 1 to get that 6. That means that our end behavior is going to be a happy face from those notes. Remember, the possibilities are from the notes, and if you need to, you can go back to that either the previous video, which has a link to my notes in it if you are looking for it. So we have that little happy face going, which means for our actual graph, which I'm going to do in green, it means on the far right-hand side, this graph is going up. On the far left-hand side, the graph is going up. We don't know exactly where it is, but it's going up somewhere. To continue on with the rest of this question, we have done the main part of the numbers 1 and 2. We've done the zeros, multiplicity, and the end behavior. If you want to be fancy with it, you could write, as x goes to infinity, all that stuff, but we're not going to worry about it for this video. Continuing on, we have x equals 0. There's our first 0 to write down. We have x equals 5, 1, 2, 3, 4, 5. And we have x equals -2, 1, -2. There we go. And now we just kind of got to play connect the dots. There are a few of them that are nice and fast. So like when you're connecting down to this -2 right here, you just kind of connect down. If you do want to be a little bit fancier about it, maybe you'd have yours go kind of more straight up from this -2 because it doesn't actually go off to the left if you were to graph it. But this is a rough sketch, and this is good enough for me and my class. If your teacher or professor is a little bit more strict, please be careful with that, and maybe you'll double check your work on Desmos. After you've done that, you've connected the dot to there. You now need to connect to the next dot. The only way to connect the next dot is either to go up above or down below. In order to figure that out, we need to look at the multiplicity. So at -2, it has a multiplicity of 1. Multiplicities of 1 always cross directly through. After that, we have to go back to this last 0, and you got to go up to there. Many students will ask, how do you know how low this goes? And unfortunately, you can't answer that until you've taken a calculus class. what you'll do is you'll be taking the derivative of the function, setting it equal to 0, finding the critical points, deciding which critical point relates to this one, blah, 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 blah. It's not important to you right now. The point is you can draw it either going that low, you can go it way down here if you want to, but it's got to go back to that 0 eventually, and that 0 has a multiplicity of 2. Even powers like 2, 4, 6, etc. always have a bounce, so it's going to bounce off the axis there. This last one has a multiplicity of 3, which is going to cross in a curvy fashion, which means that we have to go back to this, but we need to cross it in that like kind of S formation, like it's like a cubic. And there we go, our final answer to the question. Let's look on to the next one. So for the next one here, we're going to do this one a little bit faster because I've kind of already explained how to do everything. So this one we're going to kind of go at a more quote-unquote regular pace. So regular pace here, we have x is equal to 1. This has a multiplicity of 2. Don't be tricked, by the way. Just because there's a negative sign out here doesn't mean there's an answer of 0. It's only because there's an x out front. Then we also have x is equal to negative 2, and that has a multiplicity of 1. We have x is equal to negative 4. That has a multiplicity of 1. And then we got x is equal to 6, and that one has a multiplicity of 1. From all of this together, we can now do our leading term. Our leading term is that negative sign. We got an x squared, we got an x, we got an x, we got another x. That's going to be negative x to the power of 5, which is a negative odd, looks something similar to this. Which means for our actual graph that we can go ahead and get going on it. I should have done that in pink. I did that in pink on the other part of the question. Whatever. So we have going up over here on the left, down over here on the right, and our zeros at 1, at negative 2, at negative 4, and at 6. 2, 3, 4, 5, 6. Anything else I wanted to say about this one? This one's a little bit different because you haven't plugged in 0 yet. Because you haven't plugged in 0, many teachers will end up wanting you to actually plug in 0 to figure out what the y-intercept is. So if you did do that to figure out the y-intercept, you'd be plugging in 0, which would be just negative 1, negative of negative 1 squared, times 2, times 4, times negative 6, because if you make this 0, the x's kind of just disappear. And if you use your calculator to multiply all that out, it'll be negative 1 times 8 times negative 6 will be positive 48. So you know somewhere up here it's going through the coordinate 0, 48, but we haven't actually labeled our axis, so we can just kind of put it wherever the heck we want, and I'm going to say, boom, right there, there's 0, negative 0, 48. Right there, there's my 0, 48. Anyways, playing the rest, we got to play connect the dots, so we're going to play the connect the dots down here, down to this negative 4. Every single one of these has a multiplicity of 1, except for 2. With this value of 1 right there. So they're all going to go straight through except for 1, we're going to bounce. So we're going straight through, and then at 1 is where the bounce occurs. So we're going to bounce off of that, and then straight through again for all of them. Just got to play connect the dots. Honestly, this one's probably not the best because there is a rule that a line has to pass the vertical line test. So this is a vertical line here. It looks like it goes through twice. So I would actually take off points of my own graph. To be honest, I would make it sure that I would be much more careful. That's probably a little bit better doing it like that. So maybe this is not the best, and I apologize for having a bad answer, but you really can't have it crossing 2 points at once. Not a good answer. Either way, I'm satisfied with my answer, and I'm moving on. Here we go to question number 3, the last one for this quiz review here. We're going to go ahead and start the same exact idea. For the first one, we have 2x minus 1 is equal to 0. You'd actually have to solve first. So adding 1 to both sides and then dividing both sides by 2, you have x is equal to a half. But my trick is, if you want to do it fast, you just do 1 over 2. You switch the sign to make it positive. This one has a multiplicity of 2. The other one's obvious, of negative 7, also has a multiplicity of 2. Our leading term here is negative 3 times 2x squared times x squared again. The negative 3, the 2x squared, the x squared, which is going to be a total of negative 12x to the power of 4, which is a frowny face negative x to an even power. So we're going to go down over here, down over there, and we have zeros at 1/2 positive right there, and then negative 7. So 1, 2, 3, 4, 5, 6, 7. Oops, I'm going to have to rewrite my arrows. It's going to have to be over here. Either way, you're now going to play connect the dots, and we're bouncing off of both because it's a multiplicity 2. So you tap it and you bounce, you tap it and you bounce. We're done. If we wanted to figure out where that 0 was, we could. We could actually label it, and we probably should, just in case those professors want it when you go to college. Plug it in 0. Oh my, that's a big number. Negative 100 and 49 times 3, negative 147. So that's right there is, of course, negative 147. Definitely. Judging by the graph, which is why we haven't labeled the tick marks at all, by the way. Much easier to deal with the X tick marks, not the Y tick marks. Hopefully that was a good enough video. Have a wonderful rest of your day, guys. Bye-bye.